Welcome to our video lesson for evaluating functions. We're going to be looking at function notation and how we can evaluate our functions using specific input or output. To begin with, for our first example, we see that we have k of 5. So that tells me to look at my function k, and I'm going to replace x with that value of 5. And what we'll see here is instead of negative 5 times x, we have negative 5 times 5 plus 10. And if we simplify that, we're going to end up getting negative 15. Looking at our next example, we have h of negative 4. Again, we're going to look at our function h. We're going to replace our x value with that negative 4. And we're going to need to make sure we pay attention to our order of operations here. We have negative 2 times negative 4 squared plus 6. Negative 4 squared is going to be a positive 16. So we have negative 2 times 16 plus 6. And if we simplify that, we get negative 32 plus 6, which is going to be negative 26. All right, what I want you to do now is go ahead and attempt your turn problem. So try and evaluate f of negative 10 and h of 3. Go ahead and hit pause now and then try them on your own. All right, so checking your work with mine, hopefully we got the same answers. For f of negative 10, I got negative 62. And for h of 3, I got negative 12. All right, what we're going to do now is try and evaluate functions using a table. So we're going to go ahead and look at our table examples here. And what we see here is we have some domain values and some range values. Our domain is going to consist of these numbers here, and they represent the miles that you have traveled. And then the range values are going to be on the right side, our y values, and they're going to represent the charge that you incur for traveling a certain amount of miles. Looking at that first example, we see c of 3, which means that my domain value is 3. If I look at 3 here, and I go over, I can find the corresponding range value, which means that the cost for driving 3 miles is going to be 28. Or $28. And again, that's our meaning. If you've driven 3 miles, then you have a cost of $28. For our second example there, c of 1, we're going to go over to our domain value of 1. We look at the corresponding range value, and we see that it's 14. So then the cost for driving 1 mile is going to be 14. We're going to go backwards now. Given our description, see if we can write the notation. So for our description, we see that the charge is going to be the charge for 5 miles is going to be $42. And if we try and rewrite that, our function again is c. So we're going to have c of 5, because that's the distance we're driving, is going to equal $42, because that is now the charge that we get for driving 5 miles. Similar to the last example, I want you guys to try these last two. So go ahead and hit pause, attempt them, and then check back in to see how you did. Okay, let's see how we did. So for our c of 4, we look at our table. We see that it's going to be $35. So then that is our notation. Again, the meaning would be if you've driven 4 miles, you have a cost of $35. And then for that last example, we know the charge is 21. So if we look at 21 and we go over, we see the miles driven would be 2. And for our notation, again, c of 2 would equal 21. All right, we have a similar concept here, but now we're going to apply our function notation or function input and output concepts to a graph. And we again have our domain values and our range values. For our first example, I have s of 7. Now, this notation always gives me my x values or my domain values. So I'm going to go over to 7 on my graph, and I'm going to go up, and we're doing our best to kind of estimate this, and it looks like it's going to be 10. So then for that s of 7, I would put that it is equal to 10. Now for our meaning, we want to go back to what we're talking about here. X values is time, and then the y values are your speed, a speed of a snail in this case. So after 7 seconds, the snail is traveling at a speed of 10 centimeters per minute. Looking at that next notation, s of 6, similarly, we're going to go over to 6 on our x, or on our domain. We're going to go up, and this one's a little harder to estimate. It's between 9 and 10, so we have to do our best to kind of guess what that is. And I'm going to say that's going to be about 9.7, maybe 9.8. And again, for a meaning, we'd say that after 6 seconds, the snail is traveling at a speed of 9.8 centimeters per minute. All right, looking at our next example, again, we're going backwards. We have our meaning, our description. We want to go backwards and write the notation. So we can see that after 12 seconds, we're going at a speed of 8. And I want to verify that's correct. So I'm going to go to my graph. I look at 12, I go up. And then when I go over, I can see it definitely is going to be at 8. So this is definitely correct. So then for our notation, we can say that s of 12 is equal to 8. All right, go ahead and attempt these last two here. Looking at your graph, try and interpret the range for a given domain value, and then go backwards and write the notation for a given description. Hit pause now, and then check back in with your answer. Okay, hopefully your answers match up with mine. Now this S of 11 is going to be a little tricky because at 11, we are not at an exact value, so again, we're estimating, and I said that's a little bit less than half, so I put 8.4, but 8.5 is close, maybe even 8.3. And then for our last example, since we know that the speed is 7, I'm going to go up to 7, and I'm going to go over, and I estimated that to be about 1. I know the grid lines are not great on this graph, so we're really estimating, but we get something about S of 1 is equal to 7. All right, we are almost done. We're going to go ahead and look at a graph and evaluate things similar to our last example. No context here, just some domain and some range values. We have some input and we have some output. So to begin with, we have f of -8. Now these values, all of them are domain values. They are x values. So we're going to go left to right on our x-axis and then up or down to our graph to figure out what the corresponding range value is. At -8, we see that we have a choice here. And the importance of this example is whenever we have a choice, we always pick the solid or the filled in dot or line in this. So since we have a closed dot and an open dot, we're picking that closed dot. If we go over to our range values, it's going to be between -3 and -4. I'm going to go ahead and just say -3.5. Again, we're estimating here because our grid lines are not great. At our next example, we have f of -3. So I'm again going to go to -3. I'm going to go to my graph again. We're estimating here, but that seems to be pretty clearly at 2. And we don't really have decisions to make here. There's only one thing we have to choose from because we don't have that open and closed situation. So we're going to go ahead and say 2. At f of 2, we're going to go positive 2. We're going to go up again. We have to kind of estimate here, but that seems to be pretty close to 3. So we're going to go ahead and just say it's 3. Again, we're estimating these because our grid lines are not clear and it's not an exact value. For f of 6, again, we're going to go over to 6. I'm going to go up. Now I have this decision to make again. I have an open circle and a closed circle. At the open circle, the function does not exist, right? So we have to pick that closed circle, and then that looks to be at 5. So we're going to go ahead and say 5. All right, one last time, I want you to go ahead and attempt E and F. So hit pause, try those problems, and then check back in to see how you did. All right, so the answers I got for f of 9, I put 2.5. Again, we're kind of approximating here. If I go over to 9 and then I go up and I go over, it's a little difficult to figure out exactly what that is. So I said about 2.5. And then f of 10 pretty clearly is going to be that 0 value. All right, that does it for our lesson on evaluating functions. Hopefully this was a good reminder. There is no homework, so enjoy that. But check back in tomorrow for your next video on 1.5.